For 3.4, we're still working on the distributive property, and this is part 2 of that video. Only 2 examples this time. But for example 4, we're talking about a real-life application. So you might come across a word problem that looks like this. Jose is X years old, and his brother Felipe is 2 years older than Jose, and their Aunt Maria is 3 times as old as Felipe, so they want you to write and simplify an expression that represents Maria's age in years. One way to start working on an expression is to kind of look at the relationship that these three have based on the word problem. So we can do it in kind of a table or a chart form if we just kind of think about who and then how old it says they are in the problem, and then think about how we could represent that as an expression. So in the problem, it says that Jose is X years old. So we're going to go ahead and use X to represent Jose's age, and so you can just kind of do a quick fill in there, and we'll just make the expression the X without all of the labels and things like that. And then it tells us that Felipe is 2 years older than Jose. So if you think about however old Jose is, Felipe is 2 years older than Jose. So if we're doing 2 more years, then basically what we're looking at is X, however many years Jose is, plus 2 would be an expression that we could use to represent that one. And then finally, it asks us about Maria, and it says that she's 3 times as old as Felipe. So we'd have to remember the whole age here. So again, if we just kind of write out just a general idea, it's 3 years older than Felipe. And so we would have to take 3 and multiply it by that whole expression above that is representing Felipe's age, X plus 2, and be 3 years older than however old he is. So you could kind of think about that, and then it says write and simplify an expression that represents Maria's age in years. So if we were to do this with the 3 times the X plus 2, then here's where the distributive property comes in. And I'm going to just move a couple of things up here so that we can have some room to show that. So if Maria's age is equal to 3 times X plus 2, then we've got to multiply the 3 times the X and the 3 times the 2. So we would do that as 3 times X, and then add that, because again it's an addition right here. Add that to 3 times 2, because you've got to have the 3 multiplied by both parts. And then to simplify, you can't get 3x to go any lower, so it just stays 3 times x. 3 times 2 is 6. And so that would be your final expression for Maria's age, would be 3 times x plus 6. The more we work with algebra, the more you'll hear this phrase like terms come up. So you might want to have a good definition for that. So you'll write this one down. In an algebraic expression, like terms are terms that have the same variables that are raised to the same exponent. And we haven't gotten into many variables with exponents yet, but those come in down the road. But for instance, anytime you have x's, those are the variables that are the same. They can be combined. If you had y's or any other variable letters, they could be combined with the same letter, but you couldn't, for instance, combine x with y because they're 2 different variables. So constant terms, and remember constants are any numbers that have no variables attached to them, are also considered like terms. And I'm going to show you a quick example of that here. If you have this as your example, 5x plus 19 plus 2x plus 2, then you could say the 5x and the 2x are considered like terms because they both have the variable x attached to them. And then you could say the 19 and the 2 are also like terms with each other. They're not like terms. Whoops, sorry, my pen went a little crazy there. they're not like terms to the variables because these ones don't have an x attached to them. So they're like terms with each other. And the next example we're going to work with, you're going to be remembering and learning how to combine like terms. For example 5, our direction is simply to simplify each expression. And again, what we're doing is we're looking for like terms here. So we're going to use some of those other properties that we've been talking about to try to get those like terms close together. And then we'll simplify using the distributive property if necessary. So right now, when I'm taking a look here, I can see some like terms already, but they're not close enough to each other. So I'm going to do a little bit of moving around. So I'm going to switch the 3x, I'm going to leave the 3x, but I'm going to switch these two terms around so that the 2x is closer to that 3x, and then the 9 is a little bit closer to the 5, and then nothing's happening with the 5. And remember, when you move the order around but don't change anything else, that's considered using the commutative property. So we're just still continuing to label those to make sure that we understand it. And then what we're thinking about here is the distributive property. And again, this is going to be different each time. But if you think about these coefficients right before the x, what you're thinking about is 3 plus 2, and each of those being multiplied by the x right here. So 3 times x and 2 times x is what it means. And then nothing is changing with the 9 minus 5 just yet. And then if you think about 3 plus 2 altogether, backing up just a quick second, we're using the distributive property here because we were thinking about multiplying the 3 times the x and the 2 times the x. So just to give that a name so that you see when we're using it. But altogether that means we have 5x, and then over here we've got the 9 minus 5, which is 4. So we've got a plus 4 because that's what the addition sign said, and we can't go any lower than that. So that's our final answer because we can't combine the constant to the variable. For letter B, it's y plus y plus y. And again, we're not going to always write out all these steps, but in the beginning parts of this, we need to know why we do what we do. So one thing we talked about in one of our earlier chapters is that when you have these variables and they don't look like they have a coefficient, remember that's technically the coefficient, that hidden coefficient of 1. So you've got 1y plus 1y plus 1y. And if you think about what's being multiplied here, you've got 1 plus 1 plus 1 all times the y right there. So you can kind of work backwards with that distributive property there. And so basically up here you've got the multiplication property of 1 that we talked about, because anytime you multiply something times 1, you keep its identity or it stays the same, so the y's stay the same. And then here is that distributive property, which we'll keep practicing. And then altogether, these 3 ones make 3 times y for your final answer. And again, very soon, I promise, you'll be able to just kind of skip from these 3 y's down to here because you will understand that that's what that means. But in these early stages, we're just making sure you understand how we got from here to here using these different properties. For letter C, they're throwing a little challenge our way. And again, we're going to use the distributive property here to try to get like terms together. So nothing's going to happen with this 7z, but right off the bat you might have noticed that there's the 2 on the outside of the parentheses, and we were learning how you can multiply anything outside the parentheses by each of the terms inside. So really what we're doing is 2 times z, and then remember that you have to use the correct sign, and this one is a subtraction sign. So we're going to bring that down, and then we're going to do 2 times 5y, because that's the other term that's in the parentheses. So we'll write it like that. And then when we go to simplify it, this is still 7z. This is now 2z minus, and then 2 times 5 is 10, but it's 10y because that was up there. And then we're going to try to, again, simplify our like terms. So this is a z and this is a z. So it's the same thing as saying 7 plus 2 times those z's minus minus 10y. And then 7 plus 2 is 9 and that times z would be 9z minus 10y, and that's the end because you can't combine the z's and the y's, the two different variables, and so kind of just practicing that you can simplify an expression, get it as low as you can, but you might still have different variables involved. For the answer for number 2, your original expression was 8 plus 3z minus z. And again, remember we're getting to know that when you have the variable with no coefficient, that means one of those variables. So when we use the distributive property, the 8 just comes down. We're going to take the 3 minus the 1 and then multiply both of those by the term z. That's our distributive property right there. And then we're going to do the 3 minus 1, which is 2. So the 8 comes down again because there were no other constants, so that just stays an 8. And then 3 minus 1 was 2 times z, and that's as low as you can go for that one.